All right, in 11.6, we are now looking at the volume of a pyramid. Now, a pyramid, you guys have probably seen pictures. Maybe you know them to be in Egypt. You see it in movies, cartoons, you name it, and you can see the diagram right here. It's usually it consists of sides that are triangular. Okay, the triangles they all meet at a vertex at the top, and the base right there can be a rectangle. It could be a square. It could vary depending on your base. So right here, the volume of a pyramid is equal to 1/3 the capital B, meaning because that's interchangeable depending on the type of base you see in the actual figure or is described in a problem, and then times the height of the pyramid. And remember, it's going to go from the top, the tip right there, and it is going to go straight down, and it is inside of the pyramid, okay, in the middle of that base most of the time. So if right here in the second diagram you see that the pyramid is slanted and the height is from the vertex all the way down to the bottom of where the base happens to be. So that right there is pretty straightforward, pretty easy. Let's go ahead and take a look at some problems. Let's solve some out right here. Taking a look at number 1. Okay, so we want to find the volume of this pyramid. Now, if you look at the base right here, hopefully you see that the base of this pyramid happens to be, it's not a rectangle, it's not a square, it is a triangle. So, what we're going to have to do right here, and I'll highlight the base to kind of give you an idea that we are dealing with the triangle. That's where it is. So we have 1/3 capital B times H, and this time we have a triangle, so we have 1/2 base times height. So we kind of have to, we'll have two B's. We'll substitute. Let's go ahead right here. I'll have 1/2. We have a base of 6 and a height of 4. Right, that is this piece right there. So let's take this. I'll substitute that in. So we have 1/3, and then I have 1/2 times 6 times 4. Okay, that is the base, our triangular base. And then we have the height of this pyramid, and that is 9 right here. Simple as that. Plug things in, solve it out. Remember, because this is multiplication, the order in which you multiply doesn't matter. And when you put it all together right here, we have the volume is equal to 36. And since it is volume, it's going to be centimeters cubed. We take a look next up at number 2. This right here is our base. This happens to be a square pyramid because the base is a square. So we have 1/2 capital B times H. Because this is a square, and how do I know? The sides are the same right here. Then we've got ourselves 6 times 6. All right, and then times the height, which happens to be 8. Multiply those things together, you get your answer. Right, 6 times 6, 36. Take half of that, 13. Multiply it by 8, and right here, let's get our volume. Ends up being 96, and then we have inches cubed. So the only trick here is making sure you recognize what type of base your pyramid has. Let's go ahead and take a look next up at number 5. This happens to be a pentagonal pyramid. Okay, the base right here is a pentagon, but luckily they tell you that what the area of this base is, and it's 27, right? So we can go ahead and plug in 27 right there, multiply it by the height of 5. So 1/3 of 27 is 9. 9 times 5, 45. So we have volume is equal to 45 centimeters cubed. Okay. In number 6, hopefully you can see what type of a base exists right there, and that is one of a rectangle. So base of a rectangle, the equation is length times width. So let's go ahead. I'll start off once again. We got 1/3. We have uppercase B for base uh, of the pyramid, which happens to be a rectangle. So we got 1/3 base of the rectangle. 4 times 1, multiply that by the height, which is 6 right here. So we got 4 times 6, that right there is 24. Multiply that by 1/3, and you have yourself your answer of right here, 8 feet cubed. All right. When it comes to these word problems, you pretty much try to figure out what is the missing piece here. Okay, carefully read it. They tell you maybe what the base is. Maybe, and they give you the volume. So you might need to find the height, or you need to find a missing piece of that base, depending if it's a triangular base, or maybe even a rectangular base or a square base. So make sure you know the equations. You plug those things in to help you find those missing pieces. Let's jump down to number 10. Now, in the last section, 11.5, we talked about scale factor to area to volume, and we talked about the ratio that goes along with it. Remember, scale factor is just K, right? I'll abbreviate things right here. Scale factor is K. We went to area, that was K squared, and then to go from there to volume, that right there is your scale factor cubed. So right here, in order to find volume of similar pyramids, we need to use the ratios to help us find and the equal volume. Okay, so here's what we're going to do. They give us two sides right here, which happen to be the height of the pyramid. I'll go ahead. We got pyramid A over pyramid B. All right, so I'll start off, and we have 15 over 10. So let's take this right here, and I'm going to go ahead and simplify this down. And that tells me that based on the sides, the scale factor of this triangle, or sorry, this pyramid is supposed to be 3 over 2. Okay, so this right here represents K, your scale factor. Now, what I'm trying to figure out is, well, what is the actual volume of pyramid B? Hopefully we realize that it's smaller than pyramid A, so it has to be less than 125 inches cubed. Well, I can't make equal comparisons to each other right now just using the scale factor. Because remember, scale factor is in just units. Volume is in, your scale factor cubed. So what I'm going to do right here, this is scale, or instead of, it is K, or I'll go ahead and instead, let's change this to scale factor. But I want to go scale factor right here to volume. In order to go from scale factor to volume, I need to take my scale factor and cube it. So I will take this 3/2, I will cube this, and now my scale factor will be 27 over 8. So that is my volume scale factor. Remember, volume is in cubic units. So now what I do with that is set up a ratio using the equal or the proportionate volumes. So, and we've done this already when it came to area. I'll take the 27 over 28 and let's set that equal to the two volumes that we have here. And volume of pyramid A, we have 125 inches cubed, so I'll put 125 up here. The numerator, hopefully you realize I put as pyramid A and denominator is pyramid B. And then down here, that's the unknown, and then there you have is x. So now you're just going to have to solve for x, cross multiply. We have 27x, and then we take 125, multiply that by 8, and that is equal to 1,000. So if you divide both sides by 27 right here, it's approximately 37. Okay, so x is approximately 27, and then we have ourselves inches cubed. So this right here, this answer is actually the volume of pyramid B. Okay, and it is pyramid B. Thanks for watching, and I'll see you for the next section.